On BBC Radio Kent, it's just coming up to 25 minutes to 12. Yesterday, NASA made history by flying a tiny little helicopter on another world. The small craft called Ingenuity was launched on the surface of the planet from the rover Perseverance yesterday. It hovered in the air at about 10 feet before descending and touching back down on the Martian surface. This was the commentary from Mission Control.
Flight Control, confirming that we have EVRs from Ingenuity. Ingenuity is reporting having performed spin-up, takeoff, climb, hover, descent, landing, touchdown, and spin down. And altimeter data confirms that Ingenuity has performed its first flight, the first flight of a powered aircraft on another planet.
I love that sense of joy, that sense of achievement. Right, why does it matter? And what will it change? Christina Astin is going to help us with some of those questions. Christina is an education consultant, the former head of science at the King's School in Canterbury. And before that, a physics teacher. Great to have you with us on the BBC Radio Kent show this morning, Christina. How are you?
Very well. Thanks, Jules. Thanks for having me on.
It's exciting. I mean, even just listening to the audio, it's exciting if you care about these things, isn't it?
Oh, it's fantastic. I mean, it might not have looked very much. I mean, many of us have a toy helicopter or a drone, but, you know, when you see that thing worlds away on the surface of another planet, it took off for about 40 seconds, went up about 3 meters, as you heard. And, you know, it represents actually a massive milestone. It's the first powered flight on another planet. And coming, I think it's 117 years after the first powered flight on Earth, you know, that's a pretty mega achievement.
Isn't it? Yeah, yeah. I mean, when you think about the whole of human endeavour to have got from the Wright brothers to this in 117 years, we are literally flying, aren't we?
We are flying. And, you know, the technological challenges that they had to overcome to get to this point are really quite amazing. I mean, if you've ever tried flying a little toy helicopter in your back garden, you'll know that they're pretty fragile, quite hard to control. They were controlling this little Ingenuity helicopter from Earth with a kind of 3-hour time delay.
But that's the interesting thing I had envisaged as I've taken an interest in this. My children are fascinated by the whole mission. And I suppose foolishly, I, in the first instance, imagine somebody back on planet Earth with a joystick. It doesn't work like that. It can't work like that, can it?
No, it's not quite like that. They'll send the commands over to the helicopter on Mars, as I say, with this massive time lag. But then it's an autonomous vehicle, and that's what's also made it quite exciting. It's got its own power source. It's got solar cells that recharge a little battery on board. That battery also, by the way, has to control a little heater because, you know, the temperature on Mars, I know it's a bit chilly at night here, but on Mars it gets down to about minus 90 at night. And they were really worried about all the electronics freezing up. But it's the main challenge there is that a helicopter works, of course, by having these rotors going around that press down on the air, and that gives it lift to rise up in the air. And on Mars, the atmosphere is about 100 times thinner than that on Earth. It's helped slightly by gravity being a bit weaker. It's about a third of Earth's gravitational pull. But, you know, this really thin atmosphere was a massive challenge for these scientists.
So they didn't know that. I mean, you can simulate conditions, but until you do something in the flesh on another world, you can't really know what's going to happen, presumably.
You're absolutely right. And they did test it, of course, extensively on Earth. And I was just going to say that they weren't expecting to put a helicopter on this Mars mission until quite late in the planning stage. And they fixed it onto the belly of the Mars Perseverance rover. So they had to work quite quickly. And they did some testing in a special chamber that had a low atmospheric pressure sort of atmosphere to simulate that on Mars. But did you know that the highest a helicopter has ever been on Earth, it's about 50,000 meters, 50 kilometers, because beyond that our air is too thin for this to work. But this is the equivalent of a helicopter flying at 100,000 meters on Earth. So, you know, all credit. They did an amazing job.
What is it going to achieve beyond the sense? And I personally am a great believer in doing things because you can, and as long as they don't do any harm, and human endeavour and science. But does it have wider application? What does it mean for further space exploration, either of Mars or of other worlds?
Yeah, well, that's a really good question, and one that lots of people will be thinking about. In fact, the guy who was piloting it yesterday, Horvath Grip, his name was, he said in his little biography, sometimes you have to do something just to show that you can do it. And, that's good enough for many of us who are scientists, but, others will want to know, what other possibilities there are. And, hopefully there will be some spin-offs, forgive the pun. But there's a real hope that this little helicopter, and it's going to do another flight, we hope, on Thursday, and a few more test flights over the next few weeks. We'll be able to explore Mars. It'll be able to get to the regions of Mars that the rover can't get to, like cliff edges, inside craters, and so on. And, maybe there's a possibility to explore some other worlds in our solar system, like Venus, which is, a very hostile environment, Titan, which is a moon of Saturn. And, this could really open up an awful lot in our quest for finding places where humans might be able to settle in the future, or at least in the near future, to establish experimental labs and setups. I'm thinking of the kind of Matt Damon situation on Mars.
Okay,
hopefully not left there on by accident, but actually putting some scientists there to work on the planet for good.
Let's talk a little bit about the impact this has, the inspiration. You've spent a working life inspiring children to care about science, and in particular about physics. Do these events help? Do they capture the next generation?
Oh, I think they're enormously important in that area. I mean, look, young people have had a pretty tough year, haven't they? And to see something as inspiring as this, and things like the SpaceX launches and other amazing milestones in scientific endeavour, is incredibly inspiring for young people. And I was looking at that, the audio that you just played from the announcement when it had all succeeded, and you look around that control room and you see a bunch of scientists working, including some on video stream from all over the world, working together. It's a real international collaboration despite a global pandemic. And the diversity of those people was really inspiring. In fact, if you look at footage from the 1970s, earlier Mars missions, the first lander, the Viking lander in the 1970s, look at the control room there. It's
Is it all white men smoking?
Men. Exactly. So, I think that really shows young women and men of all different backgrounds that it is possible to aspire to a really exciting career in STEM, in science, technology, engineering and maths. And, Mimi Aung, who was the project manager who stood up and made the announcement after it had all gone so successfully. In fact, she ripped up the speech that she'd prepared in case it hadn't gone well, to much applause. And, she's about my age. In fact, she's featured as one of your BBC 100 Women recently. And, she's a real inspiration to inspire more girls, perhaps to study my subject, my physics.
Who turned you on to physics? Who lit that torch for you?
Well, I was lucky to have an inspirational physics teacher myself. And at the age of about 14, 15, I really got switched onto it because he showed us how physics explains how the entire world and universe works. And I just thought it was also elegant and beautiful. And a large part of the work I do now as a consultant is supporting physics teachers because as you'll know, as many of your listeners will know, there's a real shortage of physics specialists in schools. So a lot of science teachers are teaching physics outside their specialism. So I work with organisations like Physics Partners. I'm also the science advisor for Kent. So I work with a lot of schools to try and support physics teaching and to give science teachers the confidence and knowledge that they need, because ultimately that's what's going to switch people onto science.
Great to have your elegant explanation for us today. I love listening to you talking about it, Christina. Thank you so much for spending some time with us.
It's been a pleasure. Thanks for having me.
Christina Astin. She's from Astin Consulting. You've heard about all the work she does supporting physics teachers here in Kent. Former head of science herself at the King's School in Canterbury. This is BBC Radio Kent. It's 11:44.